Hey folks, how you guys doing today? This is PreCalc Appendix A1. I hope that the notes have been going well and that class is going well and that this information is helpful for you all. Please, drop me an email if there's something that could be better, but make sure that there's something that I'm not giving you a chance to look at or share, that you can give me a heads up so I can open that up for others as well as you. I will be able to, after this, to simplify and evaluate radicals and rational exponents, reduce factors, simplify rational expressions, and rationalize the denominator. Expressions using skills and properties you have learned in the past. You may be rusty. Your skills will improve by implementing a simple three-step procedure. Step 1, practice. Step 2, practice. Can you guess what step 3 is? Yep, you got it, practice. If at first you don't succeed, practice, practice again. Okay, so keep that up as we're going through. Now, radicals and rational exponents. Objective: to review the properties of radicals and rational exponents. Definition: real nth root of a real number. Let n be the integer greater than 1 and a and b are real numbers. Sorry for that interruption. Had to answer the phone. Number 1, if b to the nth power is equal to a, then b is an nth root of a. Means if I multiply b times itself n times, I will get a. If a has an nth root, the principal nth root of a is the nth root having the same sign as a. So principal nth root has the same sign of a. So if a is positive, so is the principal nth root. The principal nth root of a is denoted by the radical expression, the square root of a to the nth root. And we have an n as the index here. The positive integer n is the index of the radical, and a is the radicand. When n is odd, every real number has exactly one real nth root. When n is even, positive real numbers have two real nth roots. When n is even and the negative real numbers have no real nth roots. So keep those rules in mind as we're going through. The square root of a is the square root of a. Okay, the index n equals 2 is omitted. Okay, so this is, the index is 2. If it is a positive real number and n is a positive even integer, its two nth roots are denoted by n with the index, the square root of a to the nth power, and the negative square root of a to the nth power. So this is where, if a is a positive real number, this is positive, and n is a positive even integer, its two nth roots are denoted by this or this. Now, finding principal nth roots. Square root of 36, 6. Remember, if it's a principal nth root, the principal nth root of a is the nth root having the same sign as a. So if this is positive, so is this. This is positive, this is going to be positive. Although, because it's odd, it could be a negative value. That's what we're doing. So now I just take 27, represent it as 3 to the third power, 8 as 2 to the third power, and since it's the third, 3 is the index, 3 times itself 3 times, a 3 comes out, and 2 comes out, and it's 3 halves. Now, this is negative, and remember the principal nth root, again, the principal nth root, okay, will have the same sign. So now I'm looking at a negative sign. So I'm coming through here, and this is going to be negative. It's very similar to the last one, and that should be a negative 3 halves, and apparently it's not coming up, so it's negative 3 halves. Okay. When we're looking at D, we're looking at something that has 4 roots, that the index is 4. So 625, okay, is 5 to the 4th power, but an even number can't be negative because, a negative times a negative is positive. So not a real number at all for our answer when we're talking about the principal nth root. 5 is the index, so what number times itself, raised to the 5th power, is 32. It's 2 to the 5th is 32, so it's 2. And now we come back to our problem in D, it being positive. And we're looking at the fact that the square root of 624, or I should say the fourth root of 625, is 5. And the principal nth root has the same sign as the index, now the radicand. So now the third root of negative 27, negative 3 times itself 3 times, negative 3 times negative 3 times negative 3 is negative 3. And our last one here, as we go through, 2 to the 6th power is 64, so it's 2. I hope this was helpful with coming through with our principal nth root. Let's go on to our next page. Properties of radicals. Let u and v be real numbers, variables, or algebraic expressions, and m and n be positive integers greater than 1. We assume that all the roots are real numbers and all the denominators are not 0. Please notice this. All the denominators are not 0. So we're assuming none of these denominators are 0 in these problems. We have the property of the index being n and the radicand being uv. And I can break up the this radical, so if two things are multiplied together underneath the radical, I can split this radical into 2 other radicals multiplied together with the same index, okay, with the different radicands, u and v. Okay, and we can do that with 75, the square root of 25, the square root of 3, or the square root of 25 times the square root of 3. I can use this to help me reduce the value. Okay, I can do the same thing with all these properties. I won't run through them. They're just here for review. As I can split and do the same thing with a quotient, and I can do kind of a power-to-power move with my indices, m and n, which is n times n. So if I look at this, this is the square root of a cubed root of 7. 2 times 3 is 6, so that's actually the answer is the 6th root of 7 as I step through for my reduction. And I've got this nth root of u raised to the nth power is equal to u. So I've got the 4th root of 5 raised to the 4th power is 5. The nth root of u to the m power can be represented as the nth root of u raised to the m power. So we can break things down this way, and it'll make it a little easier. If I take the cubic root of 27 squared, okay, I can actually bring that out and say the cubic root of 27, and then I can square it. And so the cubic root of 27 is 3. I can square 3 and get 9. And you'll find that the doing it the other way works as well. Now, this is the even-odd rule. If the n, the index and the power here are even, then and it's odd that comes out, okay, I've got to do the absolute value. If the n and n are odd, then u comes out and it's positive without the absolute value. This is known as even-odd. And if it's even odd, you got to do the absolute value. So the index of 2, the square root of negative 6 squared, this is even, this would be odd. Okay, here is the power, and the absolute value of negative 6 is 6. This is odd and odd. Okay, it comes out as negative 6. You must know how to simplify radicals involving algebraic expressions, and for numerical computations we need exact answers. Remove factors from under the radical according to the rules above. So we're going to use these rules. I'm going to have you work on your own and work them out. So turn this off, give it a try, and we'll come back and we'll see how well you did. Okay, welcome back. Check out your answers. You did A. The 4th root of 80. Now I broke that down as 16 times 5. 16 has a 4th root of 2, so it becomes 2 times the quantity, the 4th root of 5. The square root of 18 and x to the 5th, I took out the things that have the perfect square So 9x to the fourth was taken out, 2x was left, and I was able to reduce 9x to the fourth, take its square root as 3x squared. Now remember the even, odd rule. If it's even index, even power, and it's an odd answer to come out, I have to do the absolute value of the solution. So it is an even, odd. So the fourth root of x to the fourth, y to the fourth, that's why it's the absolute value of xy. In D, I'm taking the third root of negative 24, y to the sixth. I can easily find the third root of negative 8 and y to the sixth, leaving the cubic root of 3 underneath, and I am able to reduce and come up with negative 2y squared, the cubic root of 3. Please keep in mind, you must show your index. If you leave the index off, we're assuming it's a square root versus a cubic root or a fourth root or anything like that. So make sure notation, 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 and pick on me about that if I missed it on something, if I got lazy. Now, rationalizing the denominator means we cannot have a square root in the denominator. Okay? Now, there will be instances that we will not have to do this, but for right now we will be, and the rationalizing the denominator, the process of rewriting fractions containing radicals so the denominator is free of radicals. Okay? Please notice, because of the different indices, I have to make sure that when I multiply something to rationalize my denominator here, I am multiplying k, the nth root of v to the k power by the nth root of v to the n minus k power, because whatever is left over has got to be n underneath, so it just comes out as v. So I have to be aware and kind of conscious of what indices I'm using, how many powers the radicand is raised to, so I can take care and meet the requirements and able for it to come out from underneath the radical. So here I've got the square root of 2 and the square root of 3. So I'm going to multiply top and bottom by the square root of 3. And when I'm done, I'm going to have 3 squared underneath, and it can come out as 3. But up top is the square root of 2 times the square root of 3, and that's the square root of 6. Now, in this next one, I got 4 as my index. This is x to the first. I've got to multiply by the fourth root of x to the third, enable for me to have it come out from underneath the radical. So now this is x to the third, or the fourth root of x to the third, times the fourth root of x, which is the fourth root of x to the fourth, which now reduces to x on the bottom. And on the top, it's the fourth root of x to the third. You guys try C, D, E, and F and see how well you do. All right, welcome back. Hopefully you did well with these. Let's step through C. Remember, this is y to the third, okay? Well, this is y to the second. Y to the third, y to the second, y to the fifth. So then I'll be able to take out a y. I multiply top and bottom based on what I need to extract the square root, or the get rid of the radical on the bottom. Okay, so I don't worry about what's on top, I worry about what's on the bottom. So y to the second makes that y to the fifth, and I'll be able to extract the y out from underneath the radical. So I multiply that out, and my answer is here. Okay. Remember, indices, pay attention to it. Multiply by the square root of 3 over the square root of 3, and I get 2 to the square root of 3 over 3. Here I'm going to multiply by that cubic root of x on top and bottom, because that'll be x to the third on the bottom. And I'll be able to extract it out from underneath the radical, and it'll just be x. And the last one, I multiply the top and bottom by the seventh root of a to the fifth, because 5 plus 2 is 7, and that way a is on the bottom, and whatever's left over on top just comes along for the ride. Okay. Now, we have reviewed exponential expressions with interval exponents such as x to the third, x to the fourth is x to the seventh, x to the third raised to the second is x to the sixth, x to the fifth times x to the negative 2. I'm just going to add the exponents. That's x to the third. and x to the negative 2 is the same as writing 1 over x squared. Exponents can also be rational numbers. 1/2 x to the raised to the 1/2 power times x to the 1/2 power is equal to x to the first power. This suggests that x to the 1/2 is equal to the square root of x. Now, let u be a real number variable or algebraic expression and n an integer greater than 1. Then u raised to the 1/nth power is equal to the nth root of u. If n is a positive integer, m over n is a reduced form and all roots are real numbers. Then u raised to the mnth power equals the quantity u raised to the 1 over nth power to the m power is equal to the nth root of u raised to the mth power. And u raised to the mnth power is equal to the quantity u to the mth raised to the 1/nth power, which is still the nth root of u to the m power. So either way how I look at this, how I break this down or this down, the numerator m of the rational exponent is the power to which the base is raised. Okay, the base is raised to the mth power. This is the power is raised up. The denominator n of the rational exponent is the root to be taken. So that's the root, that's why it's on the bottom. So pay attention to that as the notation comes through. Now, u raised to the mnth is equal to the nth root of u raised to the mth power, okay, must be in reduced form. Mnth must be in reduced form. The example u to the 2/3 power equals u to the cubic root squared is defined for all real numbers u. Every real number has a cubic root. But now keep in mind, if I hadn't reduced it, it's the 6th root of u raised to the 4th power. It's defined only for u greater than or equal to 0. So only non-negative real numbers have 6 roots. So by rule, we have to make sure it's in reduced form for us to use it. Converting radicals to exponents and vice versa. I've got a radical, it's raised to the exponents, it's 3. Raised to the 3rd power, it's square root. Okay, and so make sure that I'm comfortable with my fraction skills as I'm doing this. This is 3x times x raised to the 2/5 power. Okay, now this is 2/5, this is 5/5. So I can combine this as 1 power as 3 raised to the, it's 3 times x raised to the 7/5 power because it's 5 over 5 plus 2 over 5, which is 7/5. X raised to the 2/3 power, y to the 1/3 power. Now, because they're both indices of 3, this is cubic root, so it's the cubic root of x squared times y. This means that this is in the denominator. Okay, this is reciprocal. So the first thing I'm going to do is do reciprocal, but z raised to the 3rd is the square root, and that's all in denominator. Okay, and now because I cannot have the denominator as a square root, I gotta rationalize it based on the rules we're using. And since this is 3, I've got to make it even. I'm going to multiply by z more, the square root of z, and I'm going to get the square root of z over z squared for my final answer. An expression involving powers is simplified if each factor appears only once and all exponents are positive. So give example 5 a try on your own. Go ahead, turn off the tape, give it a try, and you'll be able to check your answer in a little bit. How did you do? We've got x squared, but it's the cubic root of x squared, so it's x to the 2/3 power. and y to the 9/3 power, but 9/3 is the same as 3. And then it's multiplied by xy squared. So now I've got 3 over 3 plus 2 over 3 is 5 over 3. And y to the third plus, y to the third times y to the second, and I just add my exponents, it's y to the fifth. So be comfortable with using your fractions as exponents, because combining the exponents when the bases are alike, when we're multiplying, is a necessity to make sure that we can simplify the expression. There's some pre-work in these. When you're doing it, you multiply the numbers together, okay? And I've got 6 x to the 2/3 power minus 1/2 power, because remember, I'm combining like terms with the exponents. Y to the 1/2 power times y to the 2/5 power is 1/2 plus 2/5. And now I just get my like denominators and combine my roots. This is an intermediate step. Their next one's probably here, but now this is the 9/10. Remember, this is y raised to the 9th power, but it's the 10th root of y raised to the 9th power, so I've got to multiply by y to the 1/10 power and able to rationalize the denominator and just make it y. I hope that went well for you. If you got questions, we can follow up further time in class. Now, combining radicals. Now, keep in mind the goal here is to get the radicals to a point where they have the same radicand inside. So the square root of 80 is 16 times 5. The square root of 125 is 25 times 5. So I'm going to have 5 here. And so I'm going to break it down to the square root of 16, the square root of 5, make the square root of 80. I got the square root of 125, which is the square root of 25 times the square root of 5. This is 5, the square root of 5. This is 4, 4 times 2. Okay. And we're just breaking it down. So I got that 4 times 2, which is 8. Now, I treat this like it's 8x minus 5x. 8 square root of 5 minus 5 the square root of 5 is 3 the square root of 5, and that's my final answer. In B, I have an even, odd, so it's got to be an absolute value. I left it in there so it's obvious that that's what be the case. This is the square root of y cubed, so 1y comes out, y squared, and y the square root of y. And now I've got this is y, this is y. Now the square root of y is going to be on the outside, and I can combine like terms there, and I'll be able to get that done. 2x minus y times the square root of y. 36, the square root of 36 is 6. The square root of 24 is 2 the square root of 6. So now I can't combine this any more than just reducing. What I'd like you to do is give D, E, and F a try using the similar stuff that we just did in A, B, and C. Okay, turn off the video and give it a try. And then turn it back on to check your work. Welcome back. Now remember, this is 24, and that's the square root, the cubic root of 8, I should say, times the cubic root of 3, because 8's a perfect cube. 81, the perfect cube is 27 times 3, so the cubic root is 27 and 3. And now I break it down, and I have 2 the cubic root of 3, 3 the cubic root of 3, 3 plus 2 is 5, so 5 the cubic root of 3. Make sure I show my index, okay, because I just can't drop it and have the square root of 3. This is 25 times 2. This is 16 times 2. I got them going. So the square root of 25, the square root of 2, the square root of 16, the square root of 2. So it's 5 the square root of 2 plus 4 the square root of 2, which is 9 the square root of 2 as I reduce. Now it's 96. 96 has a fifth root, which is 32 times 3. And 3 is just going along for the ride, but it doesn't seem like it. I really looked at this 3 to help me with this 96. So I've got my indices of fifth root. The fifth root of 32 times the fifth root of 3 is the fifth root of 96. And I got the fifth root of 3. Well, the fifth root of 32 is 2. And so I've got 2 plus 1, which is 3. So 3, the fifth root of this 3. Now, simplify radical expressions. Remove factors from the radicand. That's the example 2 for an example of that. Eliminate radicals from denominators and denominators from radicands, excuse me. Eliminate radicals from denominators and denominators from radicands. See example 3 for that. That's right up there. And combine sums and differences of radicals if possible, for example 6. So just make sure you're stepping through. If you have any questions, let's chat about it in class. And there we go. We got PreCalc Appendix A. A.1. The assignment is page 782, numbers 1 through 81, odds. Thanks for your time, folks. I hope things are going well. Remember, let's correct online, ask questions in class, and make sure you're showing your work.